Today we are talking about plyometric training. Plyometric training is a training that allows a muscle to reach its maximal force in the shortest possible time. Plyometric is a combination of Greek word that literally means increase measurement, where plyo means more, metric means measure. Let's talk about the purpose of plyometric exercises. The purpose of plyometric exercises is to increase power of the subsequent movement by using natural elastic components of both muscle and tendon, and also stretch reflex. Also, when used correctly, plyometric training has consistently shown increase in the production of muscle force and power. Now let's talk about physiology and mechanics of plyometric training. So there are two proposed models which are said to help majorly when it comes down to the increased power production of a muscle when plyometric training is incorporated into a training program. Number one is known as the mechanical model, and number two is known as the neurophysiological model. Let's talk about mechanical model of plyometric training first. So in mechanical model, the elastic energy in the musculotendinous unit increases and then gets stored when the muscle goes through a quick and rapid stretch. And immediately after, if the muscle's action is a quick contraction, the total output, the force output of the muscle increases as the stored elastic energy is released. Of the mechanical models, many elements, it is the series elastic component which is the major workhorse of the plyometric exercises. It's important for us to know that while series elastic component does include some muscular components, the majority of series elastic component is constituted by the tendons. Let's start with the neurophysiological model of the plyometric training. There are two things that we have to understand here. First one is muscle spindles, and next one is stretch reflex, because they're interconnected. So let's start with muscle spindles. Muscle spindles are sensory organs which are very sensitive to the rate of the stretch and the magnitude of the stretch. When they are activated, they send a signal to the brain, and then brain sends a signal back through the spine to the stretched muscle to shorten. Now, the signal was sent by muscle spindles because they are sensitive to the lengthening and the quick rapid stretch of that muscle. But that quick reflexive action of shortening the same muscle is known as stretch reflex. Now let's understand this with an example. As you can see, this athlete performing squat jump on the screen is going through the muscle spindle and also stretch reflex activity at the same time. As the muscles engage in this activity, lengthen, a signal is sent to this athlete's brain to shorten it. Now, as it goes to the brain, it travels back through this athlete's spine and comes back to the lengthened muscle and tells it to quickly shorten it. The shortening of this lengthened muscle is known as stretch reflex. However, the lengthening of the muscle was sensed by muscle spindles. So, difference between mechanical and the neurophysiological model of the plyometric training. The difference is, in the neurophysiological model of plyometric training, brain and spinal cord are engaged, whereas in the mechanical model, everything happens inside the musculotendinous unit. There are some examples of plyometric exercises: squat jump, box jump, depth jump, clap push-up, depth push-up. Alright, and at the end, both a mechanical model and neurophysiological model contribute towards plyometric exercises. But to which degree each model contributes is uncertain till date. I hope this was helpful. See you again with more knowledge and more topic.